little bit from our previous lesson yesterday when we learned about parallelograms and we learned about their 5 properties. All right, so let's look at this first one. What are those symbols indicating to us? Which one of those things at the bottom? Good. Opposite angles are congruent. That's what those arcs mean. Okay, what about this second one? Which property is that showing at the bottom? Opposite sides are congruent? No. Look at that. You're getting lazy. That is not showing opposite sides are congruent. It's actually, dun, 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 not a parallelogram. Anyone know what it is? What is it? I'll wait for you to type it. The next one is showing one of our properties. Consecutive angles are supplementary. Good, Kendra. It's a kite. Okay, the next one is showing our good old opposite sides are congruent. That's what tick marks indicate. Sides are congruent. And that last one is showing those diagonals. Yep, they bisect each other. 3 is congruent to 3, and tick mark is congruent to tick mark. All right. So, the title of today's lesson is Proving Parallelograms. Here's the thing about today. You are given a quadrilateral. Yesterday, you were given a parallelogram every time. Today, you're given a quadrilateral. That means a shape with 4 sides. It's your job to confirm if it's a parallelogram or not. We need to decide how many things do we need to check. Remember when we proved triangles guilty of being congruent? We're like, hey, do we need to check all 6 angles and all 6 sides? Because that would be 12 things, and that's a lot of work. And we found those shortcuts. Angle, side, side, side. We're like, oh, thank goodness. We don't have to check 12 things. We only have to check 6 things. So how many things do we need to check about a parallelogram to say, yep, that is for sure a parallelogram. It is nothing else? How many properties do you think we need to check? So good. We only have to check 1 property. Isn't that great news? And here are your choices. I need you to write these down somewhere. I know you're going to feel like I'm just writing down the properties all over again, but that last one is actually different. So I want you to write these down maybe on the back of your family tree if you want. Any one of these, any one, can confirm that our quadrilateral is without a shadow of a doubt a parallelogram. Let's talk about them. Key word here. Both pairs of opposite sides need to be parallel. If you can show that's true, that's the definition of parallelogram, so yep, it's a parallelogram. Next one. Both pairs of opposite sides are congruent. Oops, that was way too big of a tick mark. If you can show that 1 property, you're done. Don't look at anything else. It is a parallelogram. It can't be anything else. Can't be a trapezoid. Can't be a kite. Both pairs of opposite angles need to be congruent, not just one. 1 pair will not do it. Yes, you need to confirm that they both are. The diagonals need to bisect, this is important, each other. One of the diagonals can't just bisect the other, they need to bisect each other. Both diagonals need to be bisected. This last one is different. You haven't seen this before. This is not one of the properties, but it will prove that a quadrilateral is a parallelogram. 1 pair of opposite sides can be both parallel and congruent at the same time. Let me show you what that would look like. Tick mark, arrow, arrow. Parallel and congruent at the same time. Has to look like that picture. They can't be separate. Here we go. Determine whether the quadrilateral must be a parallelogram. Explain. So these are yes or no problems. Get your checklist out. Take a look at A, and if A fits any of the things on that checklist, it is a parallelogram. What do you think? Yes or no? Look at A. The second thing on your list says both pairs of opposite sides are congruent. Okay. Is this side congruent to this side? Yes, it is. Is this side congruent to this side? Yes, it is. Are both pairs of opposite sides congruent? Yes. Is this a parallelogram? Yes, it is. That checklist is the least it's allowed to do. It can totally have more qualifications. It can be overqualified for the job. It just can't be underqualified. Next one, try letter B. determine if the quadrilateral must be a parallelogram? The answer is no. Oh my heavens. Are the diagonals bisecting each other? No. One diagonal is bisecting. One diagonal was bisected, but we don't know anything about the other. That could be a kite. It could totally be a kite, and we'll learn more about kites next week. Next one. Let's get our first one right. Yes! Both pairs of opposite angles are congruent. Both. So it's a yes. Next one. This one takes a little bit more thought. I'm going to give you some time. When you see alternate interior angles that are congruent, the first thing you're allowed to mark is parallel sides. The thing that you're allowed to mark is parallel sides. Now, students get mixed up. They don't know which sides to put the arrows on. So I always tell my students to draw the letter Z. It might be a backward Z. It might be a forward Z. If you draw the letter Z, you will know where to put the arrows. Make sure you're grabbing the angles when you draw the letter Z. Now, the last thing on the checklist says there can be one pair of opposite sides that are both parallel and congruent. Is there a pair of opposite sides that are both parallel and congruent? No. One pair is parallel, one pair is congruent. This one is no. Let me show you one more way you could tackle this, okay? And I love this way because students are pretty good at this way. I want you to look at it as two triangles. I have two triangles, and I just want to see if those triangles are congruent or not. Because if those triangles are congruent, then by CPCTC, this is for sure a parallelogram. All right. If I was trying to prove these congruent, I would add tick marks here, right? Reflexive property of congruence. And then, ooh, what does that spell? Side angle. Was that one of the ones that proved two triangles guilty of being congruent? No. So there's another reason why D is no. Two good ways. Okay? How is it SSA? Look at this triangle right here. Sometimes you need to redraw it to see what's happening. Angle. See how the angle is not between the tick marks? That's how it's SSA. Okay. Last one. I'm going to give you a few seconds to look at it because it also requires some deeper thought. All right, let's look at E. The first thing I would do is, because of these arcs, I would make my Z the same one as last time, and I would add my parallel line markings. All right, so you have one pair of opposite sides parallel. Awesome. I can't add anything else to my picture right now, unless you really want to add like the shared side if you're going that route. Now, angle W and angle Z are supplementary. Now, I can't mark anything on my picture that means supplementary. So when I get information like that, I usually make up numbers. So let's say I make up that this one's 100 and that this whole angle is 80. What else can I do now though? Good. I was afraid that you were going to say Y is also 80 because opposite angles are congruent. And you're not allowed to use a property when you're trying to determine if it's a parallelogram. You're not allowed to use a property. But you saw something that I didn't see, and you saw that, hey, if these are parallel lines, and this is a transversal, this is 100, therefore that has to be 80. Do you see what's going on here? Because same side interior angles are supplementary, we're not using a property of a parallelogram, we're using a property of parallel lines. Then, if you add all those up and subtract from 360, this one would be 100. So there's actually a lot of different ways that you could get yes as the right answer. Cool. Lots of practice problems. Decide whether you are given enough information to conclude that the quadrilateral is a parallelogram. Yes or no? All right, this one says WX is congruent to YZ, and XY is congruent to WZ. Is that a parallelogram? Of course. Both pairs of opposite sides are congruent. Next one. WO is congruent to OZ, and OY is congruent to XO. Is that a parallelogram? No, it is not. Although there's lots of tick marks happening, the diagonals did not bisect each other. O is not a midpoint like it's supposed to be. So this one would be no. Oh, I kind of just talked about that. O is the midpoint of WY. O is the midpoint of WY. We have that going on. Is it enough information to determine that it's a parallelogram? No. Diagonals have to bisect each other. W is congruent to Y. And Z and Y are supplementary. I'm going to do my favorite trick where I make up numbers. Is that enough information? Oh yeah. This is 100, which makes this 100. A quadrilateral has 360 degrees, so if we add those up and subtract from 360, this has to be 80. It doesn't have a choice. So yes, that's a parallelogram. Alternate interior angles. Make your letter Z or your N or whatever letter you want to call it. Arrow, arrow. This one is that last thing on the checklist. I have one pair of sides, opposite sides, that are both parallelogram and congruent. I have one pair of opposite sides that are both parallel and congruent. So that's using one of our new ones. Yes. True or false? SR is 1/2 of AK. SR is 1/2 of AK. But the diagonals bisect each other. Good. The diagonals aren't congruent, right? So yeah, it's 1/2 of, this should say PR if we wanted it to be true. That one was false. Point S is the midpoint of AK. True, yep. It is the midpoint because the property diagonals bisect each other. Angle PAR is congruent to angle RKP. PAR, RKP. Half the battle is just knowing which angles those are talking about, right? True. Opposite angles are congruent. True. ARP is 1/2 ARK. This angle is 1/2 that angle. Is that one of the properties? Diagonals bisect the angles? So no, that is not one of the properties. The diagonals do not bisect the angles, so that one's false. We're going to stop there for today. We had a few workout problems, but you'll be exposed to those on your homeworks and warm-ups and that kind of thing.